Sorry, folks, we had a little problem with the audio. One of the cables was ever so slightly out of the jack. So audio is not existent, or at least just noise in this video until about the 17-minute, 26-second mark. Sorry for the inconvenience.
we have a console that doesn't have the standard library on disk, so it's not available. And what happens is, anyways, it loads and it crashes because it can't find the module, okay? Next up, we import urlib2, or sorry, we import our custom module of HTTP import, and it's pointed at the web server that we see that's running on the right, okay? We load that into memory, and then we load HTTP, or urlib2 again, and we see a flutter of activity from the web server as HTTP import is downloading not only urlib2, but all of the dependencies, because urlib2 has a huge number of dependencies that all need to be downloaded as well, because you don't have them, okay? So that is the standard library dealt with. One more to that, okay. All right, so standard library is green, okay? So next up, let's take a look at the exe. Okay, so right now, IPy.exe is a horribly inflexible executable. Okay, so we want to make something a little bit more malleable. We pop over in Sharp Develop, or you can use Visual Studio if you want to. But Sharp Develop actually has some really good features for IronPython that I prefer, and it doesn't make you sign in with a Microsoft account. So. So this is basically if you're familiar with C#, you have your IronPython assemblies on the left, and then the blue code in the center, that's your actual Python code, and the rest is just wrapper code that invokes that Python code. Okay. And when you execute it, it executes your Python code, and you're good to go. Okay. So we'll have a demo of this later in the talk. But for now, when you compile this, you get an exe called whatever you wanted to call it, and it's much more malleable. You can put a GUI on it. You can have it run other things. You can do whatever you want, whatever you can do with a regular C# program. Okay. Next up, we're going to look at these 4 DLLs: this IronPython.modules, IronPython.dll, and the 2 DLLs that make up the dynamic language runtime, okay? And we kind of are going to deal with them all in the same way, okay? So the first way that I looked at was doing this with IL merge, okay? And this has been used by C# developers for years. It was made by Microsoft, and I don't think they like that they made it, but they did open source it. But it is horribly inflexible, and it's a horrible project. I mean, it really is. So Microsoft is the reason we are not using that. There is a great tool called Costura, okay? It's part of a larger project called FODI, and Costura is Spanish for weaving, I believe. And so the idea is you weave your assemblies into the exe using sort of resource packing, okay? So exes can have resources, which are typically things like text files and images, that type of thing. And so what that means is that at compile time, you go from a DLL to a compressed resource that is loaded into the exe, and you can do that with multiple DLLs, okay? And then at runtime, those DLLs are uncompressed and unloaded as resources, and then loaded directly into memory as assemblies, okay? Very nifty trick. Our stripped down in Python environment is 2.4 megs at this point, right? So, like, without the standard library, a 2.4 megabyte payload size is pretty incredible as far as I'm concerned. I was still unhappy with this number, and actually, the good thing about Costura is that many legitimate applications do this, so it's not even a good IOC for people to flag on, because there are so many legit applications that use this. If you've ever used SharpHound, SharpHound uses Costura to bundle all of the dependencies that it has. into one exe. Okay. So, but that leaves us with a 2.4 megabyte payload size, which I was kind of unhappy with because it was still bigger than I wanted. And so what I'd considered doing was encrypting the resources as they were loaded into the exe, which might be an interesting project. And so I sort of dug into it, and I read how the project works. And if you were at the talk yesterday, you know, the same information is here. So Jeffrey Richter talks about this concept of embedding resources as emerging as a method of merging assemblies. Okay, and so this is the code that he has from his book called CLR vs C#. Jeffrey Richter is a guy who worked at Microsoft, or works there. I don't know if he still does. And what he figured out is really clever. Okay, I saw this code, and like the first time I really understood it, I was like, wow. This guy was thinking outside the box. This guy would have been an incredible hacker, but he probably chose another path. But basically what he figured out is that, remember how I said when an exe executes, that is a .NET executable, it checks the file system for all those places, right? So it looks in its own folder, it might look in a subfolder or a statically set folder, it looks in the global assembly cache for those DLLs, right? And if it doesn't find those DLLs on disk, it crashes, okay? But right before it crashes, it does what's called an assembly resolve event, okay? That is essentially an exception, raises an exception. And what Jeffrey figured out is he could catch that exception with an assembly resolve event handler. So he could write a custom handler in order to deal with the exception. So right before it crashes, he says, wait, I have a way for you to deal with the fact that you can't find these DLLs before you crash. Okay, and there's two basic arrows here. So the first arrow, it says, hey, I've got this DLL that you're looking for in this resource. And in the second arrow, it says, that resource that I've now unpacked, just execute it and load it into memory and then continue to keep running your program as normal. Okay, and so you can do this for each of the DLLs that you're missing. And so his idea was to embed them within the exe. I looked at this code and I said, so he's taking data from what seems to be a very arbitrary location, and then he's executing it. There's probably some interesting stuff that I could do with this, right? And so I said, let's try to load it over HTTP or HTTPS. And so instead of loading it from a resource, you load it over HTTP. You use the web client to download it over the web, okay? And this example is loading it over a local host, but it works across the internet. It doesn't care what, what your browser policy is. Doesn't care. Okay, it probably cares about proxies, but other than that, it doesn't care if it's a trusted site or anything like that. Okay, so this gets our initial payload, our initial exe, down to about 5 to 10 kilobytes, basically dependent on how much text you need to stuff into the exe. Okay, and I like to call this dot over .NET. Because I think .NET over .NET communicates what you're doing here. You can also do it with PowerShell. Kind of defeats the purpose, but it's a nifty. It just shows you that you can do this with other .NET languages. So if you're, the one F# developer at DerbyCon, you can do it with F# too. And our payload size is even smaller in PowerShell. Okay. So if you want code examples, my GitHub has a repo that has these code examples in them. So I'm loading a whole bunch of stuff over HTTP or HTTPS. Where am I serving this stuff from? Well, it turns out that the Empire listener, the Empire server, is a Flask web server. Okay, so you can say, hey, I've got this folder of stuff. Serve it at this location. Or I've got these DLLs, when somebody comes looking for them, serve them, okay? So we just host all of the things that we need to load over HTTPS in the Empire server. And so what I've done is I've modified the setup file for Empire to download and insert these files into the correct locations when you set up Empire, okay? All right, so that takes all of our, so we've got the standard library fixed, our Python Python interpreter is in good shape, and the DLR is in good shape. Okay, so we only have one file that hits the disk, and that is the exe. All right, let's take a look at what this looks like. So we've got the Empire listener starting up. We've got a folder with an 8 kilobyte exe. We launch it. It pulls down the standard library, okay, or it pulls down the DLLs, it pulls down the standard library, and then, I can't see it, it's at an angle, but the green text shows that we have a shell. Okay, so execution of a Python Empire stager on a Windows host. Okay. We also have modules. Okay. So I wrote a mini dump module that basically takes arbitrary processes and dumps memory for them when you have the permissions to do so. Okay. And I borrowed this code from a guy named, I think it's a guy, Scalsec, who is writing a pure Python implementation of Mimikatz, which has me very interested. But they wrote a mini dump library that was perfect for what I needed. I had to backport it to Python 2.7 because IronPython's Python 3 support is not great yet. But the other thing I had to fix was, so this library does a very traditional C low-level Windows API implementation of getting debug privileges. So it involves modifying or getting your process token and modifying it to be this and blah, 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 right? And in doing this, I found something actually very interesting. So this is sort of like, it's 200 lines of code to get debug privilege within this mini dump library, okay? And I ran into a problem where, for whatever reason, IronPython was not representing the pointers in the same way that regular Python was. And it just, for whatever reason, wasn't working. So I was messing around in the process parts of .NET. And one of the things you can do in Python that is really good is you can run dir bracket an object bracket, or you can just do a dir bracket bracket for where you currently are, and it will show you all of the things that you can do right now, okay? And I look through here, and there is this one thing in here called enter debug mode. I was like, enter debug mode? Man, that sounds cool. I want to do that. And I was like, thank you, Microsoft. And so I looked it up on MSDN, and process.enter debug mode, okay, puts a process component in a state to interact with operating system processes that run in a special mode by enabling the native property SE debug privilege, okay? I was like, yeah, that sounds like what I want to do exactly, okay? And so I spun up Process Explorer and looked at the privileges that the current process that I have, this IronPython console has, and we see SE debug privilege disabled, okay? And then we say, okay, open up the process library, get the current process and shove it into a variable A, and then run enter debug mode on it. And sure enough, SE debug privilege, okay? So you can, in 3 lines of code, whether you're in PowerShell or C# or whatever, you can get debug privilege in a way that is not so masochistic. So just a little tip for you. All right, so what's next? We've got the Python environment, we got the stager and agent working, we have modules working, okay? So pull request is next. I want to fix some bugs and do some error checking, and obviously more modules. So the cool thing about how this works is that a lot of PowerShell modules that exist within Empire can just be ported over by just simply rewriting them from .NET. And potentially differentiating the agent, so having different code that runs on the .NET side of Python versus the regular Linux and Mac side of Python. That might be detrimental because you would split the code, but it also would make it harder to test. And potentially you can load PowerShell within IronPython, which has some interesting potentials. But it does seem like there are some restrictions on how crazy you can get with PowerShell based on my testing, and potentially other assemblies. So the last thing that I wanted to talk about is something that I really wanted to get working for this talk, but I wasn't able to get. And that is Mono. So Mono is essentially an open source implementation of .NET. Okay, and you might think, why do I care about that? And then I'll tell you, it's the way that you run .NET applications on Linux and Mac. And you say, why do I care about that? Or you've just done all this work porting it from Linux to Mac to Windows, why would you go back? And that's not what I'm saying. The cool thing about Mono is it lives by a different set of rules than Microsoft's .NET framework. Okay, so their community cares not what you do with the Mono code, whereas Microsoft, some of it's open source, but they may care about it, right? So within Mono, there is a little script called make bundle, okay? And here's what make bundle does. Mono can turn .NET applications into self-contained executables that do not rely on Mono being installed or any other .NET framework, okay? So what that means is, let's say you, normally a .NET framework is installed on the host, okay? What if it isn't there? Or what if you have a version mismatch? Okay, then none of the stuff that happens above it, whether it's a IronPython executable or a C# executable or a, whatever it is, doesn't run, okay? But if you bundled Mono with your payload, you do not care what version of .NET is installed, okay? And so I think make bundle has some interesting, if we could like fork it, or the tool chain for setting up Mono on Windows is kind of gnarly because you have to like install Cygwin, and it's kind of gross, but I think it has interesting implications for running .NET stuff on Windows. So, and with that, I thank you, and you can hit me up on Twitter or GitHub. I'm also in the Bloodhound Slack. There's a PowerShell Empire channel if you want to hit me up there. See the Twitter for slides. And with that, I'll take your questions. I want to thank everybody at DerbyCon for all the volunteers and stuff that make this possible. I really appreciate it. Yeah, question.
So, a couple things. Cool research.
Thank you.
How did you try with make bundle? Is that just a giant enormous XC to fill that all in?
So the question is, why doesn't make bundle work right now? So the reason is that I tried to get it working on Linux and I tried to get it working on Windows, and there were two showstopper bugs that prevented it from working on each platform. So it needed some work to get it working again, and I didn't have the resources to do it. Yeah, so it would definitely put you in like the megabytes of size, like low megabytes, I would say. So. Yeah. Yeah. Yeah, so why the other question is why not just do this in C#? Why do it in IronPython? Because of the dynamic nature, and you can load more code after it's already started executing. And the other thing is that it just looks weird. Like, tools understand C#. It's not clear that tools that are detective controls understand IronPython at this point. So, yeah. Yeah, exactly. It's like, people understand PowerShell. They're getting to understand C#. This is another language that they probably don't understand. So. Any other questions? Thank you all. See me after if you have any other questions. Yeah.
I know PowerShell for Linux uses .4,
Right.
Instead of .NET Framework. Has there been any type of testing to be able to run the same type of script execution for .core?
Yeah, so you can run IronPython really easily on Linux. It's just, I don't know why you would in this case, but it is possible. It actually very well supports Mono, and it could support. They're working on .NET Core support right now as well. So yeah.
Yeah, I was just curious because I was looking at doing some more development for it, trying to get an understanding of it.
Yeah, the problem is that on Linux, .NET would not be reliably installed. So that's the problem. So.
Okay.
Thanks.
Thank you.
Thanks, everybody.
C# implementation by Joseph Smith. It went